Hello everyone, welcome to today's lesson. In this lesson, we will study pressure in liquid. This topic is part of the fluids chapter, where we learn how liquids exert pressure and how this pressure changes with depth and density. You will also see how these concepts are applied in real engineering situations such as dams, submarines, and water tanks. Pressure in a liquid acts in all directions. This means that liquid pressure pushes not only downward, but also sideways and upward. There are two main factors that affect pressure in a liquid. First, the depth of the liquid, and second, the density of the liquid. The gauge pressure in a liquid is given by the formula P gauge equals ρ g h, where ρ is the density of the liquid, g is gravitational acceleration equal to 9.81 meter per second square, and h is the depth. The total or absolute pressure is calculated by adding atmospheric pressure to the gauge pressure. Atmospheric pressure is approximately 1.01 times 10 to the power of 5 pascals, or 1 atmosphere. When scuba divers swim deeper into the sea, the pressure acting on their bodies increases. This happens because the weight of the water above them becomes greater. The total pressure at a depth, h from the surface, is given by ρ, g, h plus atmospheric pressure. In simple terms, the deeper you go, the higher the pressure. From this picture, we can see the water flow out from two different depths of liquid. At point A, which is closer to the surface, the pressure is lower. At point B, which is deeper, the pressure is higher. This shows that pressure is directly proportional to depth. As depth increases, pressure also increases. Besides depth, pressure also depends on the density of the liquid. The higher the density of a liquid, the greater the pressure it exerts at the same depth. For example, at 1 meter depth, fresh water produces much lower pressure compared to mercury, because mercury has a much higher density. Oil has a lower density, so it produces lower pressure. Water has a higher density, so it produces higher pressure at the same depth. This is why, at the same depth, an object in water experiences more pressure than in oil. Let us look at an example involving a hydroelectric dam. The depth of water behind the dam is 250 meters. First, we calculate the gauge pressure using the formula. Then, we add atmospheric pressure to obtain the total pressure at the base of the dam. In this example, two submarines hover at depths of 80 meters and 100 meters. Using the formula for total pressure, we can calculate the pressure acting on each submarine. The submarine at a depth of 100 meters experiences greater pressure compared to the submarine at 80 meters. This again proves that pressure increases with depth. Pressure in liquids plays an important role in engineering structures such as dams, submarines, water tanks, and underwater pipelines. In conclusion, pressure in a liquid acts in all directions, increases with depth, and increases with the density of the liquid. Understanding this concept helps engineers design safe and strong structures that can withstand high liquid pressure.